All right, section 3, we learned a lot of things about chords, right? We learned about what happens when a diameter hits a chord, which is this case, right? I've got a diameter, I know it because it's running through the center, and it hits a chord. What happens where those two meet? It bisects the chord, and it's perpendicular, and it bisects the arc. So if the diameter is perpendicular to a chord, which is what's happening here, it cuts the chord into two congruent parts, and it cuts the arc into two congruent parts. So from that, I can say that 3x equals 5x minus 12. Subtract the 5x, divide by -2, and I get x is 6. Yep. Yeah. Think about what could happen. Like I could have a chord that looks like that. Those two are definitely not two congruent parts, right? So the chord has to be perpendicular to the chord for it to bisect the side and the arc. Good question. All right, second one, find the value of x in the circle. So this time, I've got two chords that are what in relationship to the center? They're equidistant from the center. So in order to show that, I have to have the right angles, because that shows true distance, and the congruency marks, or a value in which it would show it true, which is, this case, it's the congruency marks. So these have to be here, and those have to be there in order to determine that this equals this. So 4x plus 2 would equal 18. 4x equals 16, and x would equal 4. Questions on that one? And the last one, determine whether RS is the diameter. So what would have to be true if it was the diameter? Has to be perpendicular. Good. So if this was perpendicular, because it's already bisected, right? It bisected that chord. We know that part. But then it has to be perpendicular to that chord. How would I know if that's a right angle? Evan?
I don't know if this is like the right way, but you could use side to find that the triangles are congruent.
Okay, two triangles are congruent.
And then the angles have to be congruent.
Okay. So you're saying that if these two triangles are congruent, right? If you use the reflexive side, right? That's what you're saying?
Yes.
The reflexive side would make these two triangles congruent, side, 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 right? And if that's the case, then these two angles have to be congruent, and those two angles form a line. So the only way for two angles to be the same and also add up to 180 degrees is for them to be 90 degrees apiece. Okay? Does that make sense? Yeah? Okay. So your answer would be yes. Okay. Questions on any of the warm-up? Okay, so let's flip to the homework that you turned in this morning. Monday is the 10.1 to 10.3 quiz. Okay, 10.1 was all the vocab. Okay, you should be able to identify a radius, a diameter, a chord, a secant, a tangent, a common internal tangent, well, common tangent, a common internal, common external, obviously you should be able to identify the center, the point of tangency. I would say to make sure that you know the difference, like if I gave you a circle, And something like this. If I asked you to describe what segment AB is, which of those types of parts of a circle is segment AB? It's a what? It's a chord. So what's the difference between segment AB and line AB? That's, so segment is the chord, and the line is a secant. Okay, so this would be a chord, right? Chord has endpoints on the circle, and this would be a secant. Does that make sense?
But they could be used for like the same line and thing, just it matters if it's on top of it.
So the secant implies it's extending outside of the circle. So I can have put a point out here, and I don't want to get too far in it because it's not going to happen just yet, but I could put a point out here, and I could call it BC, and I could call it segment BC, and that's actually a secant segment, okay, which we'll get to at the end of the chapter, okay? For right now, don't worry about that yet, okay? What you need to be able to differentiate between the two is if it's a line going through the circle, it is a secant, and if it stops at the edges of the circle, it's a chord. Does that make sense? Yeah? Okay. And then, obviously, you would want to know, like, tangent, if there's a point here. Going to intersect it at one point. Okay, that would be a tangent. JK would be a tangent. K is the point of tangency. Okay, hopefully this stuff is easily identifiable. The hardest part, I think, or the things that people get most confused on is the chord and the secant, whether it's got the arrows or not. So just be careful, make sure if it's got the arrows, it's the secant. And then we had talked about common internal and common external. So if I had two circles, wow, these are lovely ones. Okay, which one of those is the internal common tangent? The black line, or MN, right? Remember the chest for it is if you connect the two centers of the circles, if the tangent line runs through that, then it's the internal. So this would be internal. And if it does not, then it's the external. All right, so in 10.1 were the theorems about tangent, okay, which was 10.1 and 10.2, but I don't want you to remember what the name is. I want you to remember what they say, which says if a line is tangent to a circle, okay, if a line is tangent to a circle, then the radius is perpendicular to that tangent at the point of tangency. So that line would be perpendicular to the radius and vice versa. If a radius is perpendicular to a line, then that line is the tangent. So you can use it either way. So it will either give you something in which you're looking for one of those three sides, which you would have to do what there? Pythagorean theorem. Or it will ask you, is that a tangent? And then you'd be proving the Pythagorean theorem. So if I gave you that this was x, I'll make it easy and then we'll go back and show you how this could be harder, okay? Let's say it's this, and I'm saying find the length of the radius. You would have to have a right angle there, and from that you could say that x is what? What's the triple? Blank, 12, 13. Come on, Ava.
5, 12, 13.
5, 12, 13. Okay, that's one way you could see this, is actually finding the missing length. Okay, the other one is if you're given, you're the triples person.
I know.
You now have a very important job. Okay, if I was given the 5 there without having, see if it'll let me erase it, without having the right angle, nope. The question could be, is this tangent? And then your answer would be yes, because 5 squared plus 12 squared equals 13 squared. Does that make sense? So it's either it is a right angle, find the missing side, or is it a right triangle, and you'd have all 3 sides and you'd have to prove that it's a right triangle. Okay? A way that this was in the homework, I think this is also, was it in the warm-up? It's also going to be on your review. But a way that this could get a little bit trickier is if you don't have the side length here, or I'm just going to make up numbers and hope this works. So if I don't have the value on the inside of the triangle either way, okay, they're both radii, which means they're both the same value. So whether it's an r and an r or an x and x are the same value, okay? And if this is tangent, then that's a right angle. So it will either be marked as a right angle, or you'll be told that's a tangent, and then you know it's a right angle. So if I wanted to solve for r, I have to use the Pythagorean theorem, r squared plus r plus 3 squared would equal, actually let me reverse this. No, other way, yeah. 6 squared would equal r plus 3 squared. Okay, that's the hypotenuse, obviously. It's got to go inside by itself. Does that make sense? So I would get r squared plus 36 equals, and this has to get expanded and FOILed. R squared plus 36 would equal r squared plus 3, r plus 3, r plus 9. Should have grouped it. So if I subtract the r squareds from either side, subtract the 9, then r would equal 27 over 6. I told you it wasn't going to come out pretty because I just made up numbers at the top of my head. So that would be 9/2 or 4.5. Questions on that one? Because that's like, obviously, I would say that's the trickier part of this section. Good? Okay, so back. Okay, 10-2 is arcs and central angles. So this is where we learned what an arc was and what a central angle is. So arc AB is the crust of the pie, or the crust of the pizza, right? So that would be the edge of the circle that is formed by those 2 points. And then the central angle is an angle whose vertex is at the center. So this is arc, obviously this is an arc. Angle AOB is a central angle. What's the relationship between the measure of the arc that's formed by the central angle and the central angle? They're the same or congruent. So if I said that this had Let's say this is 100 degrees. What's the measure of arc BC? 100 degrees. Let's say that that really not so straight looking line is a straight line that runs through the center. What do I know about arc AB? It's 80, right? Oh, this is 100. I said 100. This would be 80, because if this is the diameter, then it cuts the circle into 2 equal parts, right? Which would be 180 degrees. And there's 3 classifications for arcs. There's a major arc. There's a minor arc. And there's a semicircle. What classifies a major arc? Good. Greater than 180 or greater than half the circle. Can you name a major arc in that circle that's drawn? ACB works. BCA works. Good. BAC would work. Anything like that. Anything that's bigger than half. Okay, the minor arc would be what? AB would be a minor arc, so less than 180. Or less than half the circle. AB or BC would both be minor arcs. And then semicircle is equal to 180 or half a circle. What's the name of a semicircle in this diagram? AC or ABC, BC, or CBA, same thing. Questions? Okay, we talked about congruent circles in this section, so how do I know 2 circles are congruent? Good. And concentric circles, which are the circles that share the same center, right? That bullseye looking thing. And they have to be coplanar, right? Because they have to be laying on the same direction. 10-3. Okay, so 10-3 was all about the chords. So obviously we had already defined chords, so this was applying properties of chords. Okay, and then the theorems were congruent chords form congruent arcs, and vice versa. Congruent arcs form congruent chords. So in the diagram that's there, if AC is congruent to BD, then arc AC is congruent to arc BD. So if the 2 chords are congruent, then the arcs are congruent, and vice versa. If the 2 arcs are congruent, so if arc AC is congruent to arc BD, then the two chords are congruent. AC is congruent to BD. All right, so this one is the chord and the diameter. So if I've got a chord that is perpendicular to the diameter, and I really should have written that in the other order, but it doesn't matter because it's an if and only if. Okay, makes more sense a little bit the other way around. But if you've got the chord and the diameter, yeah. What is what? And its arc. So if a chord is perpendicular to the diameter, it and its arc are bisected, so it should be R. All right, so if I've got the diameter, again, it would be either labeled as the diameter or it would run through the center. If this is perpendicular to this chord, then I would know that arc AD is equal to arc DC, and segment AB is equal to segment BC. And it's an if and only if, with me, which means it's true vice versa. If these things are true, then I know that DB is the diameter, or DE would be the diameter. Okay? So it works one way or the other. And then the last one is that if two chords are equidistant from the center, then the chords are congruent. And in order for this to work, remember you've got to have that they are equidistant, and the way we show equidistant is that they would have to have right angles and be congruent. So if those two things are there, then I can say that AB is congruent to CD, or vice versa. If AB is congruent to CD, then I would know that they're equidistant from the center. Okay? So those three theorems are both if and only if, which means they work both ways, forward and backwards. Okay? So the quiz review is on the actual quiz assignment. It is a non-submission because I'm going to post the answers to it. Okay? But it is there. It's not a separate assignment. Make sure you don't forget that it's there. Your quiz is Monday on 10-1, 10-2, 10-3.